All right, we have just one more, I guess, thing to throw into the basket full of ways to solve systems. So yesterday in your video, you watched me solve systems of equations, and you had to use elimination, but this time you had to multiply one of the equations by something in order to get a variable to cancel out. What we're going to look at today is when you have a system of equations and you actually have to multiply both equations by something to get a variable to cancel. So if you look at this one, number one in your notes here, if you're thinking about adding the two equations, if you did that, you wouldn't get any variables to cancel out. And so the strategy was then, okay, can I multiply a constant by any one of these equations and then perhaps add them together and get something to cancel? But that's not going to work here. So what you're going to have to do is you're going to have to multiply something into both equations. So first start coming up with a strategy in terms of what variable you want to cancel out. Do you want to cancel out the x terms or the y terms? So I'm going to go for canceling out the x terms. And what I'm going to do is I'm going to multiply the top equation by -4, and I'm going to multiply the bottom equation by 3. And you'll see why I do this here in just a second. So when I multiply the top equation by -4, I'm going to rewrite that down here. So -12x minus 8y equals -4. When I multiply the bottom equation and I distribute the 3 through, I get positive 12x plus 9y equals -6. So look and see what happens now when you add the two equations. Your x terms are going to cancel out. So you have to come up with a strategy like I did up here. I multiplied by -4 and 3. You've got to come up with something like that so that one of the variables will cancel. So my x terms are gone. -8y plus 9y is positive 1y, and then that's -10. All right, so there's one of our variables. All right, so now we can figure out what x is by just plugging it back into either one. So 3x plus 2 times -10 equals 1. So 3x, and then this is going to be minus 20. Okay. All right, so our solution is 7, -10. All right, let's try another one just like it. So example 2, same thing. If you thought about adding the two equations, nothing would cancel, no variables would cancel. So your strategy then becomes, can I multiply one of the equations by a constant so that something will cancel? And it actually doesn't work. You have to multiply both equations. So last time in example 1, I canceled out the x terms. I'm going to just show you that you can cancel out the y terms as well. So I'm going to multiply the top equation by -5 and the bottom equation by 2. Now when I distribute, I'm going to get -15x minus 10y equals -85. And in the bottom, I'm going to get 4x plus 10y equals 52. So in this problem, I just wanted to show you that you could cancel out the y terms as well. So it doesn't matter, either way works. You can cancel out the x terms or the y terms. Doesn't matter. So when I add down, I get -11x. My y terms cancel. And then if I add on my right-hand side of the equation, I've got -33. That means x is equal to 3. All right, so really quick, I can plug this back into any equation. Well, I'm just going to use this one. So 2 times 3 plus 5y equals 26. 6 plus 5y equals 26. All right, so your solution is 3, 4. Again, I always say this, but make sure that if you're on a test or quiz that you check your answer so that you're not missing any points. Okay, here's another one just like it. So we can either try to cancel out our x terms or our y terms. It seems like if I look at my x terms, I might be multiplying by a little bit smaller numbers, so I'm gonna do that. I'm gonna multiply the top equation by 5, and I'm gonna multiply the bottom equation by just 4 because one of the coefficients on the x terms is already negative. So when I go to add the equations, it's going to cancel. So I don't need to multiply by anything negative. All right, so the first equation here is going to be 20x minus 40y is equal to 75. Bottom equation is going to be negative 20x plus 40y is equal to negative 120. All right, so when I go to add these, the x terms cancel, but so do the y terms. So I've got nothing on my left-hand side of the equation. On my right-hand side, I end up with negative 45. So this solution, this is a false statement. So when you get a false statement like this, the answer is no solution. All right, let's do one more. And this is a word problem. All right, so the OSU concession stand sold a total of 138 small and large popcorns. A small popcorn cost $2.50, a large popcorn cost $4. The total popcorn sales were $466.50. How many large popcorns were sold? There's the question. That is going to motivate your variables. So I'm going to say X is the number of large popcorns and Y will be the number of small popcorns. And you guys should be pretty good at this by now, coming up with these two equations. I'm going to come up with my system. If I sold a total of 138, I know that X plus Y is equal to 138. Whoops. I also know that I had a total of $466.50 in sales. So you have to ask yourself, how can I use that piece of information in terms of X and Y? Well, you're going to sell, or you're going to, the cost for each small popcorn is $2.50. So, and the cost for each large popcorn is $4. So I can come up with this cost here. So the cost for my large popcorns is 4x, and the total cost then for my small popcorns is $2.50y. Okay, now you can use elimination here. You can multiply probably the top equation by a number, and you can just add down. That works. I'm just going to refresh our memory about substitution. So I'm going to solve this with substitution. I'm going to solve this equation here for y. So y is equal to 138 minus x. Now if you remember substitution, you're going to take that expression now is y. You're going to take that expression, you're going to plug it back in to the other equation. So this is going to be 4x plus 2.5, and now y is no longer there. It's 138 minus x. That's what goes in there for y. And then that should equal 466.5. Alright, so now it just becomes a matter of doing some algebra that you guys know. So this is going to be 4x, and then this is going to be plus 345, and then minus 2.5x. Now your job is to combine like terms. So on the left, I notice that these two are common or like terms. If I add those, I get 1.5x, and I still have that plus 345. And then I'm going to subtract the 345 on both sides, so 1.5x is equal to 121.5, which means last step, x is equal to 81. Alright, and so the question asked me to find the number of large popcorns. And X is my variable that gives me the number of large popcorns. So I can say 81 large popcorns. All right. That is all.